Okay, so let's go ahead and take a look at the formal definition of a parabola, and then we'll look at how its equations are formatted, and then I'll show you a couple of examples. So here it tells us that if we're given a fixed point F and a fixed line D in the plane, then a parabola is the set of all points xy such that the distance from F to xy is equal to the distance from D to xy. Now that fixed point F is what we call the focus of the parabola, and that fixed line is what is called the directrix. If you look at the diagram, they're telling us here that we have a fixed point F, that's this guy right here in the center, that's called the focus, and then we have this fixed line called the directrix. The parabola is the curve, okay? It's this U-shaped curve, and by definition, if you take any point on that curve, measure the distance from that point to the focus and to the directrix, and those two distances will always be equal. And that will be true no matter where you're located on the parabola. So they happen to mark the point xy here, but if I were to mark it over here to the left, if I look at that point and I measure this distance to the focus and this distance to the directrix, those two distances are exactly the same. And again, that would be true regardless of where you're located on that curve. So now that we know the formal definition, let's take a look at the equations. There's two formats. The biggest difference when you're looking at parabolas, these are the only conic sections where you only have one of the variables being squared. So notice for a vertical parabola, that means it's going to open up or down, you're going to have x minus h squared equals 4 times p times y minus k. Now I'll tell you what that p value means once we get to the actual example. Now notice in that equation, you can find the focus by using the coordinates h and then k plus p. The directrix would be y equals k minus p. Here's the best interpretation of this. For the vertical parabola, start by identifying your vertex. Your vertex is going to have coordinates h and k. Now, this number p is going to show you the distance from that vertex to the focus and to the directrix. Now, if p is a positive amount, you're going to open upward for the parabola. If p is negative, it opens downward. Now, on the next option, you've got a horizontal parabola if it's the y variable being squared. Again, let's jot down, they don't include this, but your vertex would have coordinates h and k. This p number is basically giving you the count from the vertex to the focus and the directrix. If that p number is positive, we're going to open to the right. If p is negative, we're going to open to the left. And again, for a parabola, note there's only one second degree term. There's only one variable that's being squared. So let's turn over, and I'm going to show you a couple of examples because I know that's a lot of information, and we want to make sure we understand everything that's going on. So in this example, this is our first parabola example, and they're asking us to find the vertex, the focus, the directrix for the parabola defined by the equation y squared equals 24x. Then they want us to sketch the graph, including that focus and directrix. So we need to start with the equation itself, y squared equals 24x. Notice the squared term is on the left, the non-squared term is on the right. Now we don't really have any completing the square or factoring that we have to accomplish here. All we need to do first is identify the coordinates of the vertex. And remember, I've shown you this with the ellipse and the circle and the hyperbola. If you don't have any numbers associated with the x and the y, you could just write them in as y minus 0 squared equals 24 parentheses x minus 0. That's a little cumbersome, but certainly it's equivalent to the original, and this more clearly identifies the coordinates of our vertex. So let's go ahead and jot that down. Your vertex here would have coordinates 0, 0. I'm going to go ahead and mark that on our graph. The next thing I want to focus on is this number that's out in the front on the right-hand side. Now that's going to lead us to our p-value, which is the count or the distance from our vertex to our focus. Now if you look at how those equations were structured, it was always 4p out in the front. So basically what you want to do is factor that number as 4 times whatever other factor is going to get you to 24. In this case it's 6. So 4 times 6 and then x minus 0. And so again, when you look at that, certainly it's equivalent. 24 is the same thing as 4 times 6. The reason I write it that way is because now I can see that that p-value is 6. So p is equal to 6. Now what that shows us is how far from the vertex that focus point is going to be located. Also notice, because the number out front is positive and because the y is being squared, we can tell that this is going to open to the right. So if the y is being squared, that's a horizontal parabola. Okay, it's going to open left or right. If the number in front is positive, that indicates it opens to the right. Had that been a negative 24, it'd be opening left. So back to our picture. From the vertex, we're going to count 6 units to the right. That gives us the focus. So the focus for this parabola has coordinates 6, 0. If I start over and I count 6 units in the other direction, and I'm going to make a little mark over here, that's going to identify the location of the directrix. This directrix is going to be a vertical line. I'm going to go ahead and draw this in. This is located outside the parabola. So the directrix here, it's a vertical line. Its equation would be x equals negative 6. So x equals negative 6 for that directrix. Now, the parabola is going to be a curve that goes between this focus and this directrix. All we know at this point is that it has to hit the vertex point at 0, 0. To identify the rest, you can basically make a little XY chart, and you don't need a whole lot. Usually what I'll do for a horizontal parabola here is I'll choose the x coordinate of that focus, which in this case was 6. And what I'm going to do is plug that into the original equation for x. Now notice what happens when we do that. If I plug a 6 in here, I get y squared, and it doesn't have to be 6, by the way. It could be, you could pick something like 10, or you could pick something like 3. You could pick anything to the right of the vertex. So any x value over here would be a fine choice. I just like to use the x coordinate of that focus point. So y squared equals 24 times 6. That implies y squared equals 144. Notice when you take the square root, y equals positive or negative 12. So when x is 6, you not only have the point 6, 12, but you would have 6, negative 12 as well. I'm going to come over to the graph and add those 2 points. So 6, 12, that would be located a little bit off the grid up to the top, while 6, negative 12, that's located down here below. At this point, we have plenty to draw this in. We're going to go up and curve over. Remember, this thing is opening to the right. We're going to swing down and continue curving down and to the right. And so now we've got our parabola sketched in nicely. Notice, no matter where we're at on this curve, if we were to measure the distance from any point to the focus and the directrix, those two distances are the same. In fact, this top point, which has coordinates 6, 12, that's a good example. If I were to measure this distance down to the focus, that's exactly 12 units. If I were to measure this distance, bring it over here to meet that directrix, that's a total of 6 and 6. That distance is 12 as well. And that would happen regardless of where you're at on the parabola. All right, I'm going to show you one more example to make sure we've got all of those details. It's a little bit different way of thinking about those parabolas. It's a more formal definition. Again, they're asking us to find the vertex, the focus, the directrix for the parabola whose equation is given. We'll sketch a graph including that focus and directrix. Now notice here we have a little bit of work to do on the equation because everything is not how it needs to be formatted. So I'm going to leave the x terms on the left. Notice that's the x is being squared, so it's going to stay put. I'm going to write this as x squared minus 2x. I'm going to leave a gap. Over on the right, I'm going to have a negative y and then a minus 9. So negative y minus 9. Now I need to complete the square. Now I'm only completing the square for the x because it's the only square variable. Remember to complete the square, take the x coefficient, negative 2, cut it in half, that's negative 1. I need to square that to get positive 1, and that's what I'm going to add in the gap. And of course I have to add the same amount over on the right hand side. So this process we're pretty familiar with. The biggest difference is noticing how you're only doing that for the one variable. So this trinomial on the left, remember that's called a perfect square trinomial, that factors as x minus 1 squared. On the right, combine your like terms, so that's a negative y and then minus 8. Now the left-hand side at this point is done. That's x minus 1 squared. On the right-hand side, I need to write that as 4p and then parentheses whatever the y and constant happen to be. So in this case, we need to factor out this negative. So I'm going to bring out a negative, and then in parentheses, I'll have a y plus 8. This number out in front, which is really just a negative 1, needs to be rewritten as negative 4 times some p value. So we have to think carefully here. The number out front is negative 1. So if I want to rewrite that as 4 times some other factor, 4 times what gives you a value of 1? Well, 4 times 1/4. Right? That's its reciprocal. So I'm really just rewriting that number, this negative 1, as negative 4 times 1/4. The reason I do that is because I want to be able to see that so-called p-value. So notice by rewriting the equation, we can identify all of the necessary characteristics, all of those necessary features. I'm going to scroll up just a little bit, give myself a little bit more room here. But then once we get all of that information that we need, then we'll go ahead and we'll put it on our graph. So start with the vertex. The vertex here, notice your coordinates are positive 1, negative 8. So positive 1, negative 8. You can go ahead and mark that on the graph. So that's 1 to the right, 8 down. So there's the coordinates of your vertex. Now if you look, the x is being squared. The fact that x is being squared tells us this will open up or down. To decide what's going on here, take a look on the right. Notice how you've got a negative on that p-value. So this parabola must be opening downward. Now, to figure out how far we move downward to get to the focus, just look at that p-value. So from the vertex, we're going to move down 1/4 units, which means we're barely moving down at all. And this graph gets a little bit crowded. Just do your best with it. Your graph doesn't have to be perfect. We're going to write everything out. So the focus would be located at 1. I was at -8. I moved down a fourth. So that's -8 and a fourth. If you prefer that as a decimal, you could write the focus as 1 -8.25. That's fine. The directrix, start over, so go to that vertex point, go up just a little bit, just go up a fourth, and you're going to have a horizontal line. And like I said, just do your best on the graph. I know it's tight down there. So go ahead and write this equation. Notice it's horizontal, so the directrix here would be y equals, this started at 8 for the vertex. We backed up 1/4. So that directrix would be y equals -7 3/4. Or if you prefer a decimal, y equals -7.75. And I certainly have no preference. If you want to write that as a fraction or a decimal, it's fine with me either way. Now all we need are a couple of additional points. You can make a little XY chart here. This is basically just going to be opening down. We just need some particular coordinates. I'm going to start by letting x equals 0, just because it's a convenient number. When I do that, I don't have to use this standard format. I can go all the way back to the original version of the equation to get these coordinates. So if I plug 0 in on that original equation, I'm going to jot down the results here. I would have 0 plus y minus 0 plus 9 equals 0. Subtract the 9 over, so the y value is -9. So 0, -9 would be a point on our graph. Now you know by symmetry that if you moved 1 to the left and you're at -9, then by moving 1 to the right, which would be an x coordinate of 2, you must be at -9 as well. So I'm going to go ahead and add that point to our graph. So this parabola, this little fella down here, right, opening downward, do your best with the graph. The graph doesn't have to be perfect. I realize everything is really tightly clustered there. So just do your best with it, but it's important to understand from that vertex, you counted p units down to get to the focus. We went up to get to the directrix. All right, so that does it for section 4.4, the hyperbola and the parabola. If you need to go through any of that again, especially on the parabola, I feel like is the tricky one because it's so different from the others. You know, the circle, the ellipse, even the hyperbola, all of those kind of work the same way. The parabola is really its own thing. So if you need to revisit any of that, watch the example again, make sure you're taking good notes. And then once you're comfortable with the material, go ahead and try your assignments. Your worksheets are all on Blackboard. And if you're having any problems, if you need some help, please send me an email. I'd be glad to help you.